is actually, we did this a little bit the other day. It was actually a question or two on that little quiz that you took yesterday as a way to kind of see what we remembered. After the end of the day, those two questions on the quiz that we didn't go over, that a lot of us missed, we should now be able to do. So we talked the other day about the word circumference. And one of the things we talked about is the circumference of a circle is kind of like the perimeter of the circle. So perimeter technically is never really used with a circle, but it's effectively the same thing. How long around the circle would we be? The way we find the circumference of a circle, this is the one that I like, but you will absolutely see sometimes the circumference of a circle written as 2 pi times your diameter. So either 2 pi times your radius or just pi times your diameter. Those are the two different formulas. They mean the exact same thing, right? Because twice r isn't twice r the same as the diameter. So that's why those formulas are interchangeable. And then we know the area of a circle is pi r squared. Stuff you've been doing for years. So those two formulas should not look new to you. So 24, A and B should be pretty easy. If I ask you for the circumference of this circle, then again, use either formula. I like the 2 pi r formula. So we're just going to use the formula 2 times pi times the radius. You're going to look at your circle. We can see just by looking at the circle that our radius is 9 centimeters. We throw that into the spot for r. 9 times 2 is 18 pi centimeters. That's a perfectly acceptable answer. Yesterday on the quiz, I left one of them in terms of pi. The other one, I went ahead and multiplied it out. So if I actually did 18 times pi, is that 50 something? The decimal would be fine too. They're both acceptable. So we do that. And 56.55. So either one of those is an acceptable answer. That's our circumference. If I want the area, then we just use the area formula. So pi r squared. All we need to find that then is the radius. We can get that by just looking at our circle. Our radius is the 9 centimeters. And then we know to square that. 9 squared would be 81. We'd still have the pi. That does not get squared. And then the centimeters gets squared as well. So we would say 81 pi centimeters squared. If you don't like pi and you want to hit times the pi button, totally fine. All right, I would take either or. Okay, letter B, pretty much same thing. If I want the circumference, we're going to use our formula, 2 pi r. Now you just have to understand that this is our diameter. The radius is 1/2 of that. So if we cut that in half, that means each of these must be 8.5. So notice how this then just becomes 17 pi. That is why sometimes people just use pi times the diameter, because couldn't I just plug in a 17 right away and get 17 pi? Right, that's why those formulas are the same. All right, whichever one you prefer, go ahead and use it. And then same thing with our area, pi r squared. Our area, or our radius is 8.5. Square that. And that should be 72.25 pi centimeters squared. Or multiply the pi with it. So you're probably thinking, this is easy. I've been doing this for a very long time now, and that would all be accurate. So here's now what we really get at with these problems. And we did this a little bit in a homework assignment. We did a little bit in notes. Hopefully now we do the whole day today. Possibly tomorrow, depending when we finish. We should walk out feeling good about this now. So if I now said, what if we only want part of the circumference? So if I look at this circle, let's say instead of wanting the entire length all the way around the circle, I don't want all of it. I just wanted this shaded region. All right, so it is still a circumference. So we're going to start still with that idea. We want the length around our circle. Circumference finds that for us. That's what circumference means. If we do what we did in 23 and 24, the previous two questions, we would just go to the R spot, identify our radius in the circle as 7. We would plug that in, and we would say that that is 14 pi. This one, let's go ahead and multiply this out just for a nicer number. So what we would say is the circumference of that circle, the entire circle, is 43.98. But isn't this the distance around the entire circle? We don't want the distance around the entire circle. So right now we've just found all of this, the yellow and the blue, everything. We don't want all of that. So if I don't want all of it, how much of it do I want, Jake? We want 1/4, right? So if this is the entire length around the circle, all right, we can see pretty clearly here, if you think in terms of a pie or pizza or whatever, we only have 1/4 of that. So couldn't we now just take this answer and multiply it by 1/4? That would give us what we're actually now looking for. So if we now did that, or divide by 4, whichever you prefer, what that now gives us is basically 11. So I'm going to put this down as an 11. So if you throw that into your calculator, we find that the distance from here to here, if we were walking, would be 11 centimeters, inches, steps, miles, whatever. Okay? How did you get 1/4, Jake? What was your thought? Good. So here's long term. Most of us can look at this right away and see that's 1/4. There's not a whole lot of thought process to this. But what he saw is there was 90 degrees because we have this here. And then what'd you do with that? Oh, interesting. I like that. I'm not going to use that explanation though. That's good. So he kind of cut this in half, knew that was half of it, and then he did half of half, which is 1/4. What's all the way around the circle though? Okay. So if we ever need to convert this, when it's not a nice 1/4 that we just look at and we automatically know right from the beginning, because now let's go down here. See this one right here? If it's a 150, that's a little harder. We don't know what fraction of the circle 150 is. It's a little harder for us to kind of just look at and know. But what we can always do is take whatever angle we have, which in this case it was this 90-degree angle over here, and we just want to know 90 degrees makes up how much of 360. And if I ask you to reduce that, doesn't 90 divided by 60 give us the 1/4 that we knew we needed to multiply by? Okay? So when we ask you to find this, so this is going to be arc length. So here's our arc, and if we want to know how long it is, it's based off the idea that we're dealing with a circumference. So we're going to start with that. But that gives us the entire circle. What we need to do, just like we did up here, so if we look right here, what we then did to the overall circumference, didn't we then multiply it by whatever fraction of the circle that we actually are dealing with? And the way we can always calculate that is taking your angle. So take this is a little theta. I don't know how well we know our Greek stuff, but that little theta here represents an angle. In our case, it was 90. The one we just did was 90. And then we want to compare that to the overall degree angle of any circle, which is 360. This here will give you the length of any arc that you want. Okay, so this is our formula that we want to be using. So it's really just a circumference, and we're tacking on the angle divided by 360. So if I go to number 26, we want the length of ADE. Right, so that's what we are trying to find. The length of a circle, the perimeter of a circle, however you want to think of it, the circumference of a circle, all right, is from here to here to here, and we would always be using, in general, if it was the full circle, 2 pi r. But we don't want the whole circle, right? So this is our formula from above. We want to multiply it by whatever fraction of the circle we are actually working with. So we're going to take whatever angle makes up that arc, and you're going to divide that by 360 degrees. So the first part's what we did at the very beginning that you've been doing for many, many years. We look, don't we know that our radius is 18? So you're going to do 2 pi times 18. If you throw that into the calculator, 36 pi is the full length all the way around our circle. We don't want that. We only want part of it. So the part that we want now is whatever fraction of the circle we have highlighted here. So clearly this isn't all of it. So you're going to take whatever degree measure of this angle is, and we want to compare that to 360. So real quick, write down what degree measure we create with this arc here. All right, be careful. What degree measure does that central angle have, Jake? Good. Has to be 210 degrees. We only want 210. So it's giving you that, nice in blue. This angle here is 150. That would have given us this arc. So that's why we're not using the 150. But we know if there's 360 all the way around, the yellow angle would have been created by a central, or yellow arc would be created by a 210 degree central angle. This then is our setup here. So this is our overall. We only want to have 210 of the 360. Now you kind of trust your calculator a little bit, most likely, and we throw that into your calculator. All right. So that is 36, 1/10. Is it 21 pi? Somebody check me on that just to make sure. And if you don't want decimals, just throw that into the calculator just like it looks. Your calculators are very smart. Somebody confirm this for me. 65.97. Talia's got it. All right. That's then the circumference or arc length of ADE. Okay, yeah, Jake. How'd I get what? So I kind of did it in my head a little bit. What's 2 times 16? Or 2 times 18, sorry. All right, so I'm going to erase this, put a 36 in there. And then I just did what's 36 divided by 360, and I knew that reduced down to be 1/10. And then 1/10 of 210 is 21. And I still have the pi hanging out there. You can do that yourself, just don't put the pi in there. So do everything except pi. That'll give you the 21 on the calculator, and then just put the pi behind it, and your calculator can do that also. I'm totally okay with this answer. You just have to understand sometimes, like yesterday on that little multiple choice quiz I gave you, one answer I gave in terms of pi, one I gave in terms of the decimal. We need to be prepared to do either one. Okay. If I don't specify, then it doesn't matter. All right, 27. Take a minute now, see where we are at. First, find the measure of arc AB. So tell me the degree measure of this arc. And then once you think you know that, now we're going to find the length of that arc. So that if I was at A, I needed to go to B, how many steps do I need to take to get from A to B? All right, so take a minute or two, see if we're understanding where all this is coming from, and see if we can set that one up. Okay, give me about 30 more seconds here. See if we've got this. You need two things. This hopefully is not too bad, but you do have to remember some old stuff. And then this is the new idea. What's the length of just this little segment right here? This little arc along the circle. Okay, let's see where we are at. So if I ask you what is the degree measure of AB, you're not given that. But what we hopefully know is the arc length here, or the arc degree measure, should be the same as this central angle, right? But you're also not given that central angle. But if we think back, one of the very first things we did, and we'll probably talk about this a little more tomorrow as we start reviewing for the final a little bit. Remember vertical angles, two lines that intersect form those four angles. The angles that are across from each other have to be congruent. So these two angles here, the ones that I have in blue, these are congruent. And I still don't know any of it, right? But now we finally get to some stuff we've been doing over the last week and a half. If I know that this arc is 35, doesn't its central angle then also have to be 35? Then they're vertical angles, so that means the angle directly across from it must be 35. And then since this is a central angle, the arc that it creates must also be 35. So this is the answer to that. The measure of that degree, or that degree measure of arc AB is 35 degrees. Okay. Now the new idea, the length of a circle is its circumference. This is the entire circle though. We don't want the entire circle. So we now have to figure out how much of 360 do we have for the particular arc that we're dealing with. So of the 360, we don't have it all, just A to B. So just A to B is all we're concerned about, and that is 35 degrees. So our setup should be this. You're going to take the radius, which is given to you as 10 inches, and then we have 35 of the total of 360 here. That's what you're then throwing into your calculator. Before we kind of show what that is or whatever, we're understanding that setup, where this is all coming from. All right, then we do that. 20. That was what, 35 over 18 pi. So let me see what that is. All right, and we get 6.11. Yeah. And again, you could throw this in. Your calculators are pretty smart, unless you have a really, 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 really old calculator. If you just make it look like this on your calculator, the calculator handles all the order of operations, and it's going to give you that 6.11 right from the beginning. Okay. All right. Good. All right. Then real quick, let's try 28. So 28, a little different. I don't give you the graph. You're just given that the circumference is 150. So over here, we know the circumference formula is always 2 times pi times the radius, or again, especially for this one, you could understand your circumference is pi times your diameter. Both of those are perfectly correct. If I tell you that the circumference of your circle, so I'm now telling you the circumference is 150, tell me what the radius and diameter are. So do that real quick. What do we think? So we know our circumference is 2 pi r, and we know the circumference is 150 pi. Then we can hopefully state the radius and diameter pretty quickly. So we're a little short on time. I'm going to kind of do it the short, quick, non-algebraic way here. If we look at our formulas, isn't your circumference always pi multiplied by twice the radius? So if here is my circumference and it's pi, isn't 150 twice the radius then? Doesn't 150 have to be twice the length of the radius? If that's the case, what does your radius have to be? What do we think? It's got to be 75. So that if I double it, I'm going to get the 150. If we use this formula, it's even easier, right? Because this is the diameter times pi. So doesn't 150 have to correspond to your diameter? So that has to be a 150. You could set up an equation if you like. That's what we did last period. Let the circumference equal a 150 pi. Now, can't we just solve this little equation? Divide by 2 pi everywhere. Pi's cancel, 2's cancel, pi's cancel right here. And notice how we now get 150 over 2. That would give you your radius to be 75 also. Okay? All right. So here's what's going to happen. Tomorrow, we're going to finish these couple. That should take about 5 minutes or so because the next set of problems are almost the same exact idea. We're just going to do it with area. I'll give you the little 2 or 3 question quiz, and then that should get us about halfway through the class, and we'll start going over the final exam stuff. But just keep in mind Friday as something on your calendar that we want to know our stuff because Friday is going to be our final exam. Okay? At least the first day of it. No homework. Free to go on that. If you are home, you guys can check on out, and we will see you tomorrow. What's your computer timer set? What's your computer clock say? Yeah. So it went 18, 19, just like that. That was weird. Yeah, it's 19. You guys can go. It's weird. Yes, ma'am. I'm not sure yet, to be honest. Thanks, Ahmad. Currently, if I remember correctly, we do not have it on the final. So if I want to put it, it's going to be me doing it individually. I think each teacher will kind of decide if they want to put a couple of these questions on there. So I'm not sure yet. Okay. Yep. All right. See you, Jake. Bye, Alexis.
With the final.
You what now?
I kind of have like a problem because on Friday I won't be like.
Well, take it Monday, and then are you going to be here Monday?
Yeah, I think so. Yeah.
Can you come in second period Monday?
Yeah.
So that's what I would do. Come in second period Monday. What I'll probably have you do is just take it all in one sitting then. Okay. Although you got to come to class, right?
Yeah.
Yeah, just come in Monday. The second period is the same length as our class. And then just do one part Monday, second period, and the other part in class.
Okay.
Okay. Okay. Thanks for letting me know. Yep. Have a good day.